So natural numbers, how we just naturally count. 1, 2, 3, 4, 5, and continuing on. So only positive numbers. So now whole numbers. So whole numbers, now we can expand. Can I have -1? Is -1 a whole number? Matthew, what do you say? No. Okay. So whole numbers, think of this O in whole. We're going to start out with 1, 2, 3, 4, and continue on. Okay, so the difference between natural numbers and whole numbers, now with whole numbers, we include 0. I said negative. I think I said -1. If I didn't, that's what I was thinking in my mind. If I didn't, I was wrong. So integers now, we can include the negatives. Okay, so we think of like -3, -2, -1, 0, 1, 2, 3, ... So these are integers. There's no decimal values associated with them. We got to hit right on the numbers. Okay, rational numbers. A rational number we can write as a fraction and has a terminating decimal. Okay, so what's that mean? Like 1/4, I can write, because that's 0.25. It has a terminating decimal. There's no like 0.5 repeating or anything like that. So a rational number you can write as a fraction. So like 2 would be a rational number, because I could write it as 2 divided by 1. But it has that terminating decimal. An irrational number has that non-terminating decimal. So like pi would be an irrational number. If we want to do square root of 2, that would be an irrational number. We could get a decimal value, but the decimal is going to keep going and going and going. It's not going to terminate. It's a non-terminating decimal. Okay, and then real numbers, that's simply any number. Real numbers like the largest sets we can have. Okay, we always work with real numbers, and then we can get into subsets of real numbers. So this is just a quick review of all of the different sets that we can work with numbers, and you're going to be asked questions on Math Excel based on these sets. Okay, classify this, or what group does this belong to? So if you told me 1, I would say, well, 1 is a real number. 1 is also a natural number. 1 is also a whole number. 1 is also an integer, and it's also a rational number. All right, so that goes into a lot of sets, but then we start getting into fractional values, negative numbers, then it starts to limit our set. All right, working with exponents now. So some properties with real numbers. So if I ask you to evaluate 4 cubed, well, we know that's just 4 times 4 times 4. Okay, mental math. Jack, what's 4 times 4? What's 16 times 4? Good job. Okay, so 4 cubed is 64, but it's just 4 times 4 times 4. All right, what about -6 squared? Simon, what do you think -6 squared is? What if I wrote this as -1 times 6 squared? What would you say it is? Times -1. So this is really -1 times 36. So this actually becomes a -36. And what I want to get out of this is parentheses are important. If you just wrote down -6 squared, I would do 6 squared times -1. But if you told me in parentheses -6 squared, that does become a +36. So whenever you're doing squarings of negative numbers in your calculator, always put them in parentheses and then it won't go wrong. Because if you just type in -6 squared in your calculator without parentheses, it's going to tell you -36. But more often than not, we want it as parentheses of -6 squared. And we know if we square any number, it's going to be positive. But this one, -6 squared here in B, is really saying -1 times 6 squared. Okay. What about this one? What's 4 times 3 squared? Teddy, what's 4 times 3 squared? Correct. All right, so we'd want to do the 3 squared first. So 3 squared to get 9, and then 9 times 4. Ben, what's 4 times 3 in parentheses squared? What? Good job, because this is really 12. Come on, there we go. This is really 12 squared, which is 144. So this slide is getting across that parentheses are important. Parentheses are going to play a major part in your order of operations to make sure you're doing it correctly. What was that acronym that we use for order of operations? Does everybody remember what that is? Ben, we got PEMDAS. Okay. Taylor, what does PEMDAS stand for? Okay, parentheses, exponents, multiplication, division, addition, subtraction. So you do on your paper, do 6 divided by 3 plus 2 cubed times 5. Everybody work that out. That includes you two, Dayton, you two, Simon. You know what it is. All right. What is it? Look at that. Simon came to play today. Okay, this does equal 42. Okay, so really we have 6 divided by 3 plus 2 cubed, which is 8 times 5. Okay, there's no parentheses to worry about. We've taken care of the exponents. Our next step is multiplication, so I'm only going to focus on these two. So I still have 6 divided by 3 plus 40. Next, I want to do my division. So 6 divided by 3 is 2 plus 40. Then last, I want to do my addition to get 42. All right, so we got to make sure that we follow and not right off the bat 6 divided by 3, immediately take that to be 2. 2 plus 8 to get 10. 10 times 5 to get 50. That would be wrong. Okay, we're not just reading it left to right. We have to do our order of operations correctly. Okay, let's look at this one. The P in PEMDAS can also be treated as like a G for grouping. And when I say G for grouping, we think that the top and the bottom are separate groups. And so we would tackle this, do the top, the numerator, get a number, and then do the bottom, the denominator, and get a number, and then divide. Okay, so we do our tops first. So negative times negative 3 cubed. So first off, what is negative 3 cubed? Charlie, what's negative 3 cubed? What? Okay, negative 27, because it'd be negative 3 times negative 3, which is a positive 9. Positive 9 times negative 3 would be a negative 27. So we have a negative of negative 27, if you want to think of it that way. And so really we have a positive 27 plus a minus 5, so that's just minus 5. And so we have 22 is our numerator simplified. All right, and then in the denominator, we have two things that are being multiplied with subtraction between those. So this would be a negative 40. And then I'm going to keep it as subtraction. I'm going to treat the 5 positive. So it'd be negative 40 minus 15. Or 40. Where am I getting 40 from? I don't know where I'm getting 40 from. All right. 2 times a negative 8 is negative 16 minus 15. So what's negative 16 minus 15? Negative 31. So this becomes 22 all over negative 31. But again, they're groupings. Do the top first, then do the bottom, and then you can combine at the end, do any simplification. 22 divided by negative 31 does not simplify, does not reduce any further. All right, absolute value. And this is the last thing we're going to talk about. So again, absolute value takes anything in my absolute value bars and makes it positive because we think of it's a distance from 0. Okay, so on this one, I have 2 times the absolute value of a negative 6 minus in absolute value bars 3 times 10, all divided by in absolute value bars negative 6 times 10. All right, so 2 times the absolute value of 6 is the same as 2 times 6, so I get 12. 3 times 10 is 30, absolute value of 30 is still 30, so it's 12 minus 30. Negative 6 times 10 would be a negative 60, but it's in absolute value bars, so that's really a positive 60. (12) subtract 30 would be a negative 18 divided by 60. Can I simplify that? Is there a common multiple at the top and bottom? Of what? What's the largest common multiple? 6. Okay, so if I divide the top by 6, the bottom by 6, I have a negative 3 tenths. Would be the final answer. Not too bad, right? Shouldn't be. Okay, so this is just some review on all this stuff, working with order of operations, sets, all that. So in Math Excel, our point 2, and I'll make this available. Have these ones done by start of class tomorrow, and then we'll continue on to the next review.